Okay, today we're going to go over another example of inheritance. All right, it is a very important topic, and we're going to sort of build it from the ground up. And I already have the classes written, but what we're going to do is we're going to talk about the business situation and then determine what functions we have and where they should be and so on. All right. By all means, if you have any questions at all, please let me know. In fact, if you're behind and you're not up to the current assignment, let's do this Wednesday. If you're working on anything earlier than that, please send me an email just to touch base and let me know where you're at and what obstacles you're running into, what issues you're having, and I'll do my best to get you back on track. All right. Anyhow, in this case, what we have is we have sales reps. All right. There is this company. There's three kinds of sales reps. There's the regular sales rep. There is a junior sales rep, and then there's a senior sales rep. The difference about them is, of course, how much they get paid. All right. The sales rep's pay is comprised of their salary, their regular salary, their base salary, you could call it, plus whatever commissions they have. And their commissions are based on the sales that they have. So each one gets a certain percentage of the sales that they have. And we'll look at more details of that in a minute. But I want to sort of talk about it on an abstract level now. So what we want to know about each sales rep is their name and what their sales had and anything else. Get my example here. Employee ID. All right. So there's a couple ways we could do it, and I'll do my best to explain those couple ways. One thing you could do is you could have an abstract class. I don't think we've used the name abstract class before. An abstract class is a class that you cannot create an instance of. So we could create an abstract sales rep that has three classes inheriting from it. Sales rep, junior sales rep, and senior sales rep. And these three classes could all inherit from that. The only difference between an abstract class and a regular class is you cannot do this. You cannot say, you cannot create an instance of an abstract class. You can also define an abstract method. An abstract method is a method that you define on the class level, but it has to be overridden in any class that inherits from it. So for example, we know that all sales reps, you have to calculate the commission. We could make that an abstract method where you would just define public double, calculate commission, and you define it as an abstract class method. And then each one of these would have to override it. Now I could do that, but that doesn't really seem like the situation we have right now. I mean, this would work. I wouldn't, if you did it this way, I would not count it as being wrong. All right. But what makes more sense to me is to say, well, you know, most of the sales reps are going to be in this category. So we have our basic sales rep, and then associated with that, there can be either junior sales rep or senior sales reps. That's a little bit different. That's a special case of a regular sales rep. So what I'm going to do is I'm going to do this. If that was confusing to you, review abstract classes in the book, and there's probably some resources out there for them. But I'm going to create something like this, where I have the sales rep as the parent class. I have inherited from that junior sales rep, and senior sales rep. What are the attributes that we need for sales rep? Well, we said we wanted to have the employee ID. We want to have their name, and we want to have their sales amount. Those are the attributes that we want on sales rep. Does the junior sales rep and the senior sales rep, do either of those have any new additional attributes? And the answer is no. We did not define there being any different attributes that are different from what a regular sales rep has. So there's no new attributes. In either of these. So what method do we need? What methods do we need? We need get and set methods for each attribute. So we want to be able to get the employee ID. We want to be able to set the employee ID. We want to be able to get the name, set the name, get the sales amount, set the sales amount. Do we have to override those methods in junior sales rep or senior sales rep? No. Those are very basic functions. They either take an argument and set these attributes, or they return the value of those attributes. That's the same regardless of the kind of sales rep they have. What other methods do we have? Well, we have calculate base salary, calculate commission, calculate total pay. Total pay being simply their salary plus the commission. Which of these do we have to override for junior and senior sales reps? Well, as I mentioned, both the salary and the commission that junior sales reps and senior sales reps get paid are different than a regular sales rep. So we would have to override those functions both on the junior sales rep and on the senior sales rep. We said that there's a different rule for base salary for a senior sales rep. There's a different rule for commission, likewise for junior sales rep. Do we have to override calculate total pay? Well, I think yes, but this is a semi-trick question. All right. The reason I call it a semi-trick question is the method for calculating total pay is the same for all of them. You calculate the commission and you calculate the base salary and add those two together. So if I define that under sales rep, I don't have to redefine that under junior sales rep and senior sales rep. Now, to be sure, calculate base salary and calculate commission are going to return different values for a senior sales rep than a junior sales rep. But I don't have to declare that function because the process for getting the total salary is the same, adding those two numbers together. These are the two things that are different. Now, what about constructors? I'm going to say that on sales rep, I have a constructor that accepts employee ID, name, and sales amount. Makes sense because generally speaking, in our particular example, we need to have all those to really have a sales rep. You would also have to repeat that same constructor on both of these that accept the same arguments as the base. So what I've done is I've defined those classes. If I neaten this up a little bit, I would have what's called a class diagram. This class diagram showed in Canvas. I think, yeah, under week 6. That shows classes in rectangles, lists the attributes, and lists the methods that exist on those. The little arrow indicates that this is a subclass. So what we have is not that much different from that. We would just have to add the attribute names under sales rep and the method names, part of the rectangle, whereas I wrote them outside of the rectangle. This is actually a lot of the work of programming. Okay, this is actually a lot of work in programming, is designing the classes. Many times it's much more complicated than this. And it takes more time than we spend today. This is a very straightforward problem. 2 subclasses, no new attributes, 2 functions overridden. One reason that this is done is something like this then could be done by a more senior programmer and then handed off to a junior programmer. And the junior programmer wouldn't have to think through the whole architecture of the system. They would just need to write the relevant functions. So doing this is very important, and I suggest you do this for all your assignments, even though you think you don't need to. Plan it out. Programming is a very detailed, complex activity. All right? Any complicated, detailed activity is best if you plan it than if you try to wing it. So think it through first. This is like writing an outline for a term paper. And I hope you do that too, even though students are sometimes resistant to do that. We're not going to turn in a class diagram. All right, we're going to turn in Java code. So some students might think, well, why bother spending the time if it's not something I'm turning in? You spend the time so that you come up with a better solution, and a solution that works, and a solution that is best for the problem at hand. All right, so let's look at the code that I came up with for this scenario. Here are my 3 classes. Some of the functions might be a little bit different. Some of the function names might be a little bit different. Here's my base class, my parent class, my super class, sales rep. It has 3 attributes that are protected: the employee ID, the name, and the sales amount. It has a constructor that accepts each of these. It accepts an integer for the employee ID, a string for the argument of name, and a double for the sales rep amount. Now I'm doing this and setting those attributes directly. What I talked about last time is it's better to call the set functions. This will become more important when we start writing validation code. This is actually a preferred way to do it. We only have one way to get to that attribute, and that is through the set method. So if we put any code that does validation, we only have to worry about it in this one place, and every place is going to call that. That's actually a better way of doing it. Here I have my set methods, which are as you would expect. Right now I don't have any validation, but that's going to change fairly soon in this course, where we're going to have validation and we're going to throw exceptions. Those of you who've done C# might be aware of throwing exceptions and what that means. Here's our get methods. Instead of calc, I called these get methods too. 6 of one, half dozen the other. What we're saying here is that for a basic sales rep, a regular sales rep, the commission is 10% of the sales and the base salary is $2,000 per month, let's say, or per week, or whatever the time period is. Salesmen usually get a low base salary and then hope to make it up on commission. So we'll say this is a month's salary. And then the total salary is simply the sum of the total salary, or the base salary and the commission. So it's calling these methods. We don't need to duplicate this on the senior sales rep or the junior sales rep, because this method, this calculation, is the same for all sales rep. What's going to be different are these two functions: commission, get base salary. So if we look at the senior sales rep, notice what we have. We have just those two methods. And two methods are, they get 12.5% of their sales, plus for all their sales above $10,000, they get an extra 2.5%. So in other words, they get 15% rather for any amount over $10,000. And that's their commission. Base salary is $2,500. The junior sales rep, the base salary is $1,500, and they get paid 7.5% commission. As we said before, though, we need to chain the constructors. So in this case, we're simply having the senior sales rep and the junior sales rep have a constructor that simply takes those arguments and calls the superclass's constructor. Remember, you have to construct the superclass before you construct subclass. Since there are no extra attributes for junior sales rep or senior sales rep, there is no extra attributes involved, so we don't have any extra arguments in this, and that's all this function does, is chain to the constructor. All right, let's look at running this. Let's look at the unit test. The test is creating a sales rep. Sales rep J equals new sales rep. I have a variable called J. In it, I can store any kind of sales rep I want to. But in this case, I'm creating just a regular sales rep. So that's a legal statement. And I then call and get their name, base salary, and get their commission. This, of course, is really inadequate for testing, right? Because this is only testing one instance, one possible situation, a regular sales rep. That's why I've written down here test case 1. The implication is we'd have a whole lot of other test cases that would test other scenarios. And we'll talk about test cases in a minute here. So let's run this and see the answer we get. We should get this person sold $5,000 worth of stuff. We should get their base salary being $2,000, their commission being 10% of that, or $500. Their total salary should be $2,500. Let's see if that's what we get. So I can compile that. It compiles cleanly, and I run it. And sure enough, I get that their base class is $2,000, their commission is $500, and their total amount is $2,500. So I got what I expected. Now here's the thing. We're going to keep these test cases. Because if I go back in and I change something, unless I've changed the way that you calculate a sales rep base salary and commission, after I make changes, I'm going to test again and make sure I haven't broke something in the code. This is called regression testing. Regression is when you make a change to some code and you break something that worked before. It's a regression. Right? You went backwards. All right. So I'm going to do this. In fact, it would be good if I documented in the code what I expected the result to be. So I could say, for example, in this test code, test case 1 would be a base of 2,000, commish of 500, total 2,500. So I put that comment in so I know, and anyone testing this should know what the answer should be. Now I've started to make a spreadsheet here of my test plan. And I think the resource that I gave showed a pretty extensive base test plan. Here, I just sort of summarized it into a set of 4 columns, and these would sort of minimally be what you would need to do this kind of test. I call this test scenario a regular sales rep, or just sales rep. What steps am I going to perform? I'm going to create a sales rep. I'm going to set their sales equal to $5,000. What do I expect? I expect their base salary to be $2,000. the commission to be 500 and their total to be 2,500. And that's exactly what I got. So is there a bug? No. It's not allowing me to type that in. There we go. False. Now this is clearly not enough test cases. I haven't begun to test a junior sales rep, a senior sales rep, and so on. So I would have more rows in this. I would have a test scenario 2. Let's say a junior sales rep. And their sales were $4,000. What do they expect? What should the answer be? Let me go back and look. Should be 7.5% of 4,000 is what? Plus a base salary of 1,500. I want my calculator app here. I think. I would expect to be 1,500. Commission to be 300. And total equal 1,800. Let's test this. This kind of creating the test cases is something that a programmer wouldn't even have to do. Right? Someone that simply knew the organization and knew how much sales reps got paid to create these test cases. Let's recompile it and retest it. Oh, I didn't put the test code in. My mistake. This one's expecting a base of 1,500, commission of 300, 1,500. Okay. Equals junior sales rep. I create that. Oh. Sales rep K. I changed that. Oh, something's wrong. All right. What's wrong? Oh, they sold $5,000. This should be 4,000. You see, it's a red flag. I know I need to check something. My test case was a junior sales rep that sold $4,000 goods. could be a problem like that. Or it could be a problem in your code. But at least I was alerted to it. And I can run it and test it. And there I verify, and there I get the answer that I was expecting. The one thing that you can do that's nice in your code is to just put a line of dashes in between your test cases. The stuff doesn't run together. Remember, we don't want to spend tons of time on this unit test because this is not really part of our real application. In a real application, these sales rep objects are going to be created from the database, possibly from what users key into a GUI or some other way. So we'll have those objects created not by hard coding. All right, you would never in a real application hard code these values. But what we are doing here is we're doing tests. And for tests, we have to test for specific circumstances and make sure that we cover as many of the possible circumstances as possible. All right. Now, if I didn't know anything about the code, I might create another sales rep that was a junior sales rep that sold $3,500 and see what their calculation should be, and so on down the line. I know about the code. All right. If you don't know about the internals of the code, it's called black box testing. In other words, you can't see into the code. You don't know anything about it, and therefore your test has to, in a way, be more thorough because you're not sure what the salary depends on. All right. If, for example, there was another field, hire date, and your salary depended on the hire date, if you're not able to look at the code, then there's no way for you to be able to guess, and therefore you'd have to enter in and create sales reps with multiple different hire dates. We have an advantage, though. We can see the code, and that's called white box testing. So I know that if I test one sales rep, one regular sales rep, and I get the proper commission and proper salary, that's probably adequate. Likewise, if I test one junior sales rep, all it depends on is whether they're a junior sales rep or not. Right? Senior sales rep, though, they get a different commission whether they are, if they sold more than $10,000 or not. They get 15% on above 10,000 and get 12.5% below 10,000. First 10,000 sold, they get 12.5%. Anything above that, they get paid an additional 0.025%. Now for this, one test isn't going to be enough. If I test, for example, senior sales rep, and I create a sales object where the sales is $8,000, then they're going to get paid $2,500 plus 12.5% of 8,000. That's 1,000. Given the total of 3,500. So let's go and create that test case. That's case 3. And sure enough, that comes up with the correct answer. Okay. Now the question that some people have is, do I have to put a flag somewhere that says what kind of sales rep they are? The answer to that is no. Because depending on the class that is created, that's the kind of sales rep that they are. What if I needed to know what kind of sales rep they were? If I had a report and the report showed the type of sales rep they are. We could do that a couple ways, right? Actually do something like this. I could create a toString function. Many classes have a built-in toString function. In fact, all classes have a toString function, but they're not too meaningful unless you override them. I'm going to have the regular sales rep return the word sales rep plus the name. I'm going to have the senior sales rep return senior sales rep plus name, and the junior to return junior sales rep plus name. If I went in the unit test and I had to identify what kind of sales rep they were, I call the toString function. You would call that instead of calling the name. Sales rep, junior sales rep, senior sales rep. Okay. If I had to do something different, like for example, this comes up from time to time. What if I had a function on senior sales rep that did some senior sales rep stuff? I'm going to be very vague about this because I don't want to spend the time. It's going to return a hard-coded string, but this could be any kind of function. Maybe the returns a different attribute. What if for senior sales reps, I wanted to put that code in here. Okay, this is gonna work. This is gonna display my senior sales rep stuff. Your sales rep stuff. But what if I declared the variable this way? And this will often be the case. Maybe instead of having individuals, I have an array list of sales reps. All right. Could I put a senior sales rep in an array list that contains sales reps? Yes, I can, because a senior sales rep is a sales rep. Could I put a junior sales rep? Right, I could. But what if I declared, so if I declared something like this, I hope you can see we're going to get a compile error. Why do we get a compile error? Because we declared this variable as being a sales rep. Therefore, we can only do sales rep things to this variable. And senior sales rep stuff is not a sales rep thing. It's a senior sales rep thing. Now, to be sure, this object does have that method on it. All right. However, we can't access it directly doing this. What we can do is something like this. And I hope I get the syntax of this correct. If not, I'll look it up. Check to see, is that L object a senior sales rep or not? If it is a senior sales rep, then we can do what's called casting. That is, we can treat this variable like it's a senior sales rep. Should work. Let me compile it just to be sure. No. Again. Oh, instance of. I don't use this very often, so. It's lowercase apparently. It's the wrong class name. Sales. Your sales rep, not ref. See, every programmer has those frustrating days where they just type the wrong thing or whatever. This should work. Okay. So cannot find symbol. Oh. Yeah, that was my bad. I have to do this. Here I'm saying treat L like it's a senior sales rep and store it in a variable called S, and then I can call S dot senior sales rep stuff. And I'm able to do that. That is called casting. Casting is making sure is when you know, you can test to see if it's an instance of a class, and if it is, you can sort of make a version of that, use a different variable to create a senior sales rep variable that knows all the senior sales rep functions. If you didn't get that part, don't worry about it. It's just that some people have asked, how can I tell if someone's a junior sales rep or a senior sales rep? You could use the instance of to do that. All right. I encourage you all to ask questions. I notice that some of you are behind on coding. I'm going to have to decide how to deal with that. I want to make sure everyone has an opportunity to catch up and get even. So I'm going to figure out how I want to handle next week. So pay attention in Canvas to see how I'm going to do that. I will post this example to Canvas. That's all I had for today. We'll see you next week.